Elementary Algebra, Final Assessment Number 4, Review, Questions 8 through 12. In question number 8, we're given the trinomial y to the second plus 22y plus 15, and this is equal to 0. So I have a problem here. If I'm going to solve this, I'm going to need to factor this trinomial. I have a value in the A position, which is an 8, and a value in the C position, which is a 15. So I'm going to use the A times C method to find a value of which I'm then going to find a pair of factors who sum to the B value, or the positive 22. So let's start first by multiplying and see what our number is going to be that we start with. So we have the 8 times the 15 to get 120. Now I need to find a pair of factors that when multiplied together create a positive 120, but when summed together create a positive 22. So I've set up two lists here. And for this kind of problem, you're not going to need to run a list quite as long as what I'm going to show you here, but I'm going to run every single set of factors just as an example so we can see how this method works. So I'm going to start here with a 1. A 1 times 120 is going to equal a 120. But when I come over here to sum them, 1 plus 120 gets me a 121. Same thing with 2. 2 times 60 gets me a 120. But 2 plus 60 equals a 62. So I move on. I have a 3 times a 40 equals 120. Well, 3 plus 40 equals 43. That one didn't work. So 4 times 30 will make 120. Well, 4 plus 30 equals 34. So that one didn't work. So I move on to 5. 5 times 24 is equal to 120. 5 plus 24 equals 29. I'm still too high. So I move on to the next one. 6 times 20 is equal to 120. 6 plus 20 equals 26. I'm starting to get a little closer here. 8 times 15 makes 120. So 8 plus 15 equals 23. I'm almost there. I don't have a 9 times something that's going to get 120, so I skip on to the 10. 10 times 12 equals 120. 10 plus 12 equals a positive 22. There are my pair of factors. It's going to be a 10 and a 12. What I'm going to do with those two numbers is I'm going to come back to the original problem, and I'm going to replace this 22y to the middle with those two factors. So when I add them, I still have the same problem. So I come down here, I've got the ay to the second, plus, there's my first one, a 10y, plus the 12y, plus 15. When I sum the 10y and the 12y, I still have a 22y in the middle. But because I've done this, now I have 4 terms, and I can factor by grouping. So you can see some brackets have already been put in here around the front 2 terms and the back 2 terms. Now looking at the first 2 terms, I look to see what's the greatest common factor between the two. In this case, it's a 2y. So I'm going to divide the 2y out. So the 2y comes to the outside, and what I have left inside is whatever value results from the division. So a 2 into an 8 makes a 4. A y into the y second leaves me with a y. Carry down the plus sign. A 2 into a 10 leaves a 5, and a y divided by y, well, that goes down to a 1. So it clears out. Carry down the plus sign. Now look at the greatest common factor between the 12y and the 15. This time it's a 3. So I put the 3 to the outside, and in the parentheses I leave what I have after I've divided the 3 out. So 3 into 12 leaves a 4y. 3 into 15 leaves a positive 5. Now when I look at the page, looking from the left of the plus sign to the right of the plus sign, what I have in common is the 4y plus 5. So I'm going to divide the 4y plus 5 out now on both. It comes to the outside, so 4y plus 5. I can now cancel those out. They cancel down to a 1. And what's left up there is the 2y plus a 3. So that leaves me with my second binomial. Now the instructions were to solve. So now that I have these two binomials, now I need to set them each equal to 0 and see what the possible values are for y. So I set the 4y plus 5 equal to 0, subtract the 5 out, leave me with 4y equals negative 5, then divide the 4 out to move it away from the y, and I end up with y equals negative 5 over 4. There's one possible answer. I also set the 2y plus 3 equal to 0, subtract the 3 off both sides of the equal sign, leaves me with a 2y equals negative 3. Now divide the 2 out off both sides, and I'm left with y is equal to a negative 3 over 2. So my two answers are negative 5 over 4 and negative 3 over 2. Moving on to question number 9. Here I see that I have a 13m squared minus a 9m. I'm going to continue to try to solve for m. So in this problem, the first thing I'm going to do is look for the greatest common factor and pull it out. Between the two of them, it's just an m. So I'm going to divide both by m. The m comes outside. M into 13m squared leaves me with a 13m. M into 9m leaves me with just a 9. Now I can set each of these equal to 0 and solve. M equal to 0 is just 0. 13m minus 9 equal to 0. Let's solve. Add the 9 to both sides. This results in a 13m equals 9. Now divide the 13 out on both sides, and we're left with m is equal to 9 over 13. So our two answers are 0 and 9 over 13. Moving on to question number 10, the instructions read, multiply using the rules for special products. So here I have a 7x minus a 5y overall raised to the second power. This is going, when I'm looking at this one, this is going to be a rule where I have a squaring of binomials. If a and b are real numbers, variables, or expressions, then I can factor by using one of the two formulas below. Well, this is a difference of squares, so I'm going to use the second formula, and I'm going to plug my values in. So let me pull this up just a little bit so that we can see the original problem. My base is a 7x in the a position and a 5y in the b position. So using the second formula, I'm going to come in here and I'm going to plug in for my a squared. It's going to be 7a squared minus 2 times my a position, which is 7x, times my b position, which is 5y, plus my b position squared, which is 5y to the second power. Let's finish out the problem. So 7 times 7 is 49. A times a is a squared. 2 times 7 times 5 creates a 70. Carry down the x and the y. And then 5 times 5 is 25. And y times y is y to the second. And there's my final answer. Number 11, the instructions read, factor by factoring out the negative of the greatest common factor. And the reason I'm going to do this is because there's a negative sign in the first position. And whenever we see a negative in the first position, we're always going to divide out that negative value. If there was nothing that they had in common, then what we would divide out is a negative 1. But looking here, I have a 4, an 8, a 12, and a 16. All of those are divisible by 4. So I'm going to divide out that negative 4. Then I look to see how many x's can I divide out. This last one only has 3 x's available, so that's the greatest amount that can be divided out of that one. So the others are going to be cut off at an x to the third power. So I'm going to divide them in. The negative 4x to the third came to the outside, and I'm left with an x to the 12th divided by an x to the third, so I subtract them, 12 minus 3, to get an x to the 9th. I move on over to the next one. A negative 4 into a positive 8 is going to leave me with a negative 2, so minus 2. An x to the 9th, x to the third, so 9 minus 3 to get a 6. Moving over, a negative 4 to a negative 12 is going to create a positive. And it's going to be a positive 3. And then I'm going to subtract that 6, or take that 6 and subtract the 3 to get a 3, so x to the third. Then a negative 4 into a positive 16 is going to make a negative, and it's a negative 4. An x to the third divided by an x to the third, well, that results in a 1. 1 times 4 is still 4. Or you can say that they just canceled out. For number 12, it says factor completely. So looking up here, I can already see that I have 4 terms. But before I start grouping this thing and factoring it out, I want to see, do I have anything that all 4 terms have in common? And I do. I have a greatest common factor of 6. When I look at the variables, they don't all have the same variables in common, but they do have a constant 6, so I'm going to divide it out. So the 6 is going to divide into each, so I end up with a 6 on the outside. When it divides in, the 6 to the 6 it cancels, I'm left with an x squared. A 6 in the 6xy, I'm left with just the xy. A 6 into the 12, I'm left with a 2. And the 6 into the 12y here, I'm left with a 2y. So now I'm ready to group. So you can see in green here, I've put some brackets around here to group them. I've left parentheses to the outside to show that the 6 is all the way outside. So in the first pair, I have an x in common, so I'll divide the x out. Now the x is just coming outside this bracket. It's not coming all the way outside the parentheses yet with the 6. So I divide that x out here. So x into x squared left me with an x inside the bracket. Carry down the plus sign. And then x into xy leaves me with a y here. Carry down this plus sign to the middle. And the greatest common factor here is a 2. So I'm going to divide a 2 out. So I'm bringing the 2 to the outside. 2 into 2 canceled down to a 1, just leaving the x. And 2 into 2y cancels out the 2's again, leaving just a y. Now when I look at it in here, looking at the left side of the plus sign to the right side of the plus sign, I see that I have an x plus y in common. So I'm going to divide out x plus y. This time when it divides out, it's going all the way outside with the 6. So it's going to come out here and join the 6. We end up with the 6 times the x plus y. Then I cancel those out. What I've got left up here go inside this second set of parentheses. So I have an x plus 2. So I have an x plus 2 for my final answer here.